Alright guys, welcome to this page of the notes, and what we're going to do is we're going to go ahead and use some geometry to help us do some algebra. Right, what I've got here is I've got two triangles for you guys, and essentially what I do is I tell you that Lexi bought matching triangular pendants, one for herself and her mom, right, because she wants to go ahead and make jewelry out of them. But what I want you to do, right, is I want you to find the value for x. What value of x can you use to make these triangles congruent? So what value does x need to be so that these two triangles are congruent triangles? Well, I quickly take a look at this, and here's what I see. I see that side AC is the same, corresponding to side JL and 3 centimeters each. And same thing here, AB is corresponding to JK and 3 centimeters. So I've already got two of the pairs of sides are congruent. So this one and this one, this one and this one. Well, let's go ahead and do those. I see that AC is congruent to side JL, and I already see that side AB is congruent to side JK. Well, since I already know that two of the pairs of corresponding sides are congruent, if I can show that the third pair of sides are congruent, then I know that these triangles are congruent. So here's what you're going to do. CB is corresponding to side KL. If I set these guys equal to each other and solve for x, I will make these two sides be congruent and therefore give myself two congruent triangles. So right over here, I need these guys. I need those guys to be congruent. I need those two sides to be congruent. So side CB needs to be congruent to side KL. Well, okay then. Set them equal. 4x minus 6 is equal to 3x minus 4. Side CB, 4x minus 6. Side KL, 3x minus 4. Guys, solve for x. Simple algebra problem at this point. I'll subtract 3x to the other side, so 4x minus 3x minus 6 is equal to a negative 4, which means x minus 6 is equal to a negative 4. Add the 6 to the other side. X is equal to a negative 4 plus 6, which means x is equal to 2. Now, what does that do? Well, if I let x be equal to 2, right, plug it in. 4 times 2 is 8. 8 minus 6 would be 2. So I get that this side is going to be 2 centimeters. Same thing down here. Plug it in, plug it in. Plug in a 2. 3 times 2 is 6. 6 minus 4, 2. 2 centimeters. And what I have shown is that CB is congruent to KL by the side theorem. These two triangles are congruent. Triangle ABC is congruent to triangle JKL, right? Because I've just shown that the three pairs of corresponding sides are all congruent. And I did it doing a little bit of algebra. Let's do another one. This one's tiles, right? Adeline made a design using triangular tiles. I want you to find the value of x that makes these triangles congruent. Makes these triangles congruent. Well, okay, let's do it. Here's what I can see. Flip that guy over. So I see that this side needs to be congruent to this side. This side needs to be congruent to this side, and this side needs to be congruent to that side. And they are, right? 4 inches, 4 inches. Okay, great. So here we go. Let's write all that down. MN is congruent. Oh, that's a terrible congruent. Hold up. there we go, congruent to PQ, thanks to the diagram. Let's see, I also see that MO is congruent to PR, thanks to the diagram. So all I have to do is show NO and RQ are congruent. Okay, so let's do that then. I need to show that NO is congruent to RQ. Well, plug and chug. NO, 3x minus 11. I need that to be equal to RQ, which is 4. Solve for x. How about we add 11 to the other side? So 3x is equal to 4 plus 11, so 3x is equal to 15. Divide both sides by 3. X is going to be equal to 5. Guys, plug it in and see what you get. 3 times 5, 15. 15 minus 11 is 4. What you've just done is you have shown that NO is congruent to RQ, and by the side theorem, triangle NMO is congruent to triangle PQR. Right? Side theorem. Again, all it took was just a really simple algebra problem, but in order to set up the algebra problem, you needed to know some geometry to get it, right? I got one more problem for you guys here on the next page of the notes. Please read very carefully. Notice that in this problem, I want to know which theorem did you use. So even though this is in the section where we've been talking about the side theorem, don't get sort of trapped into the idea that you have to use that theorem. It's entirely possible we might use something else. Let's just see where the geometry leads us, okay? So here we go. I want you to find the value of x and y. So find the value of x and y that make these triangles congruent. Find the value of x and y that make these triangles congruent. Well, here's what I see. If I take this triangle right here and I just sort of rotate it over right onto this guy, right? What that tells me, right, is that G and U are congruent, right? They're corresponding angles and they're both 90 degrees. But more importantly, that tells me that angle F and angle T are congruent or corresponding angles. So let me go ahead and put that little mark in there so that I know that. So I know that those guys are corresponding angles and I need them to be congruent, right? I want congruent triangles, so angle F and angle T, I need those to be the same angle. But then please notice what else I see, right? If I bring this guy over and I just kind of rotate him in right there, that means that side GH and side UV are corresponding sides, which means I need these two sides to be congruent. I need them to be congruent. And then finally the last thing, right? That means that H is corresponding with V. That's what I need. I need H and V to be corresponding angles. I need them to be congruent. Okay, here we go. Let's do a little bit of work. Here's what I know, right? I need F and T to be congruent angles. They're corresponding angles. I need them to be congruent. So, set up a geometry problem, right? Here's what I need. I need angle F to be congruent to angle T. So, set it up. I know that F is equal to 60. I need that to be equal to 7y plus 4. Well, solve the problem. Let's subtract the 4 to the other side, which is going to give me 56 is equal to 7y. Divide both sides by 7. 56 divided by 7 would be 8. Now, right, check it. Right? If I plug in an 8, 7 times 8 is 56. 56 plus 4 is 60. I get 60 degrees. Which is perfect. That's exactly what I needed. Angle F was 60. I need angle T to also be 60. Keep going. Guys, look, I need GH, this side, GH, to be congruent to side UV. Okay, let's do that. I need side GH to be congruent to side UV. Well, plug in what we know. GH, 8x minus 12. That has to be equal to 12. Sorry, I wrote over the 12 and covered it up. So anyway, 8x minus 12 has to be equal to 12. Because again, another fairly simple geometry or algebra problem. Add 12 to the other side. 8x is equal to 24. Divide both sides by 8. X is equal to 3. Check it, plug it in. 8 times 3, 24. 24 minus 12, 12. And sure enough, 12 and 12, those guys all match up. Okay, now, do I have enough to prove these two triangles are congruent? Here's what I've got so far. I've got that angle F and angle T are corresponding and congruent. I've got that angle G and angle U are corresponding angles and congruent, and I have GH side GH and side UV corresponding sides, and they're congruent. Is that enough to prove congruence? It's not. It's not, right guys? Remember, the theorem is angle, side, angle. It has to be the included side. Since I know F, G, and TU, I need to know that these sides, this included side, TU and FG, I need to know that those sides are congruent. And look, I don't know that. Based on the diagram, I don't know that. All I know is that angle F and angle T are congruent. I know that angle G and angle U are congruent. I know that side GH and UV are congruent, but that's not an included side. So at this point, I do not have enough information yet to say for sure these triangles are congruent. So let's keep going. Please notice I told you that angle V is 30 degrees. 30 degrees. Well, what do I know about the other triangle? I know angle F is 60. I know angle G is 90. Do you guys see it? You need the triangle sum. Ooh, that got ugly on me. The triangle sum theorem. Do you remember what it says? The triangle sum theorem tells you that all of the interior angles, all three interior angles, must sum to 180 degrees. So let's do it. I can go ahead and find the measure of angle H because I know the other two. Angle F plus angle G plus angle H must equal 180 degrees. Guys, plug and chug. F is 60. G is 90. Find angle H. Okay, well, 90 plus 60, how about 150? Subtract the 150 to the other side, angle H is equal to 180 minus 150. What do you get? Sure you do. You get 30 degrees. Is that what I needed? Yeah, you bet it is. Angle H is 30 degrees, and that's exactly what angle V was. Angle H is 30 degrees, angle V is 30 degrees, and now I have enough information to prove these triangles are congruent using angle, side angle. Angle G, angle U. Side GH, side UV, angle H, and angle V. Angle, side, angle. Angle, side, angle, right? I got it right here. Those given to me, angle G and angle U. So right here, angle G is congruent to angle U. That was given. I know that side GH is congruent to side UV. I found that right here, and I know that angle H is congruent to angle V. I found that right over here, Angle, side, angle. So the angle, side, angle theorem proves that these triangles are congruent. Now, you're probably asking yourself, hang on a second, why did I even need to find y in order to prove that these triangles are congruent? Well, again, here's the reason why. In order for these two triangles to be congruent, remember, all of the interior angles must sum to 180 degrees. They must sum to 180 degrees, which means, right, 60, 30, and 90, right? That's got to sum to 180 degrees, and that will only happen if angle T is 60 degrees, right? That's the only way, right? 60 plus 30 plus 90 is 180. So since angle U is 90 and angle V was 30, angle T had to be 60 degrees. It had to be corresponding to angle F. Even though I didn't need that in my proof, I still needed that to be the case in order for the other angles to be congruent. And again, that triangle sum theorem is just what allows us for those interior angles summing to 180 degrees. So anyway, I wind up with the angle side angle theorem to show that these triangles are congruent. I found that y needed to be 8 and x needed to be 3. Guys, thanks so much for joining me for this set of videos. I had a great time going through the side triangle congruence theorem with you. Again, remember what it does is it cuts down the amount of work that we have to do. CPCTC required us to prove 6 things. 3 pairs of corresponding sides and 3 pairs of corresponding angles. Using the side triangle congruence theorem, we only have to prove 3 things. Prove 3 pairs of corresponding sides are congruent. You know the triangles are congruent. Half the work, hopefully half the time. Thanks so much for joining me. I'll see you guys next time.